Okay, so as we move into lesson 7.5, our learning goal today will be I can factor special products, two types of special products, perfect square trinomials, and the difference of squares, which is a binomial. So first of all, we got to determine when we have a special product. So if a binomial or a trinomial, doesn't matter which one now, if we have a binomial or we have a trinomial, if they begin and end with a perfect square, so this is important, if they begin and end, so in a binomial, basically both terms would have to be perfect squares. In a trinomial, the first and the third terms would have to be perfect squares. Then it is possibly a special product. So we're going to look for some other signs that will help us determine if it is what we call a special product, because then we're going to use a different method of factoring than we've learned so far. So first of all, we've got to be able to talk about what are perfect squares. We have perfect square numbers, we have perfect square variable parts. So 1 is our first perfect square, because 1 times 1 is 1. Our next perfect square would be 4. 2 times 2 is 4. So basically what we do is we take the whole numbers and square them, and we have perfect squares. So our next one would be 9, 3 times 3. Our next one, 16, 4 times 4. And we'll just keep that going until we have a good start to a list of perfect square numbers. And you really should get these memorized so that you can notice them right away. And in fact, you should memorize the perfect squares through 15 times 15. So I'll let you do that on your own. Perfect square variable parts. What times itself is x squared? X times x. X to the first power times x to the first power. Remember, when we multiply powers with the same base, we add their exponents. So the next perfect square variable would be x to the 4th, because x squared times x squared is x to the 4th. Now the next one is going to be, what is x to the 3rd times x to the 3rd? That's 3 plus 3, 6, so x to the 6th. So notice the exponents on these variable parts aren't perfect squares. It's the variable to that power that if we can find something times itself that gives us that, we call it a perfect square variable part. So the next one would actually be x to the 8th, because x to the 4th times x to the 4th. X to the 5th times x to the 5th would be x to the 10th. Notice a little pattern going on here. All the exponents are going up by 2's. So an even number on an exponent on a variable part in the exponent is going to be a pretty good clue to you that that is a perfect square. Okay, now let's narrow it down to what if we're working with the binomial? What are we going to look for? So first thing we're going to look for are both terms perfect squares. If they are, then it must have subtraction between them. There is not such a thing as addition between perfect squares to have a special product. It has to have subtraction so that it can be called one of our special products, the difference of two squares. We learned back in chapter 6, there is not such a thing as the sum of squares, only the difference of squares. So I've put some examples here for us again. We have x squared minus 25. Both terms are perfect squares, and their subtraction. 4x squared minus 81. Both terms are perfect squares. In fact, what is the square root of 4x squared? What times itself would give you 4x squared? Well, the square root of 4 is 2. The The square root of x squared is x, so 2x would be the square root of 4x squared. And then we have our 9 minus x to the 4th. Both of those are perfect squares with subtraction. So that's what we're going to look for to decide if a binomial is a special product called the difference of two squares. Because there's going to be a way to factor those that I'll teach you on the back side. If it is a trinomial, so now we have a trinomial that begins and ends with perfect squares. So the first and third terms are perfect squares. Well, the last term, not only do the first and third terms have to be perfect squares, but that third term, that last term, must also be positive. So when it's written, we should have that last term showing as a positive. And the middle term, we haven't talked about that second term yet. The middle term has some restrictions. It has to be double 2 times the product of the square root, or square roots, because each of those first and last terms, that first term will have its own square root, and the last term, the third term, will have its own square root. So we are talking about taking 2 times those square roots multiplied times each other. That should equal our middle term if it is a perfect square trinomial, if it is a special product. So example, here's our first example. We have x squared plus 4x plus 4. We look at it and say, are the first term and the last term perfect squares? They are. Next thing we look for is the last term positive. It has add 4, it is. Next thing we look for is that middle term, that 4x, does that agree with doubling the square root of the first term times the square root of the last term? So doubling 2 times, the square root of x squared is x, the square root of 4 is 2, and 2 times x times 2 is 4x. So the middle term does meet that rule. So we can say this is a perfect square trinomial. Here's another one. X squared minus 4x plus 4. First and last terms have to be perfect squares. There has to be a positive last term. And now we'll check out the rule for the middle term meeting the standard it needs to. We double the square root of the first term times the square root of the last term. So 2 times the square root of x squared is x, the square root of 4 is 2. But notice, we get the same thing, we get 4x, not negative 4x. And the reason for that is because we're going to go back here to this 2 right here, and we're going to make it negative because the square root of 4, there are 2 square roots of 4. There's a positive square root, and there's a negative square root. This one used the negative square root. So 2 times x times negative 2 does give us that negative 4x that we need for the middle term. So this one meets the standard of being a perfect square trinomial. So again, now once we determine they are a special product, I'm going to teach you how we're going to factor those on the back side. So let's go to the back. Let's talk about the binomials first. Once we've determined that a binomial is the special product called the difference of 2 squares, we've made that determination. Here's how we can factor it. Each binomial factor will begin with the square root of the first term and end with the square root of the last term with addition in one of the factors and subtraction in the other. So back in chapter 6, when we were multiplying special products, if they both started with the same term and both of the factors ended with the same term, one had addition, one had subtraction, we would end up with a difference of two squares. Our product would be a special product called the difference of two squares. So now we're doing the reverse. We're getting the product first, and then we're going to factor it, give it, what was it before it got multiplied? So here's how we'll check it out. First thing, you know what I would check first of all, is there subtraction? If it's a binomial, do you have subtraction? It does. So then we're going to say, okay, well then I'm going to see if I can take the square root of x to the 8th. Well, that happens to be x to the 4th, because x to the 4th times x to the 4th, 4 plus 4 is 8. And then I'm going to take the square root of the last term, which is 64. Don't worry about the subtraction right now. Square root of 64, we're going to go with 8. And now that I found out they are both perfect squares, I can get a square root. I'm going to set up my factors. I'm going to give it its factored name. So what was it before it got multiplied out? It says up there above, it says both factors will start with the square root of the first term. Both factors will end with the square root of the last term. One will have addition, the other will have subtraction. There's our answer. We have factored our binomial. Okay, let's look at number 2. First of all, it does have subtraction. Good news, that means it's possibly factorable. It's possibly a special product. Let's rename this one though. What is 3 squared? Well, that's 9. So what we really have here is, we've already decided it's subtraction, so now we're going to try the, can we take the square root of the first term? Sure can, it's 3. Can we take the square root of the other term? 16x to the 4th. Well, 16 is a perfect square. Square root of 16 is 4. X to the 4th is a perfect square. How do I know? Because it's an even numbered exponent. So in reality, all I have to do is divide that by 2, and I'm going to know that x squared is the square root of x to the 4th. So square root of 16 is 4. Square root of x to the 4th is x squared. They are both perfect squares. We can set up its factored name. They both must begin with the square root of the first term. So this time it's the 3. They must end with the square root of the last term. So the 4x squared. One of them needs addition, the other one needs subtraction. It really doesn't matter which one gets which. They both start and end with the same thing. So it doesn't matter which one is subtraction and which one is addition. We need one of each. That is our factoring the difference of 2 squares, binomials. Okay, now let's go on to, well, what if we've decided we have a trinomial and it is a perfect square trinomial? So we have this perfect square trinomial. We've decided that, you know what? I think it's a perfect square trinomial, so how can I factor it? Well, each binomial factor will begin with the square root again of the first term. Sounds familiar. They will begin with the square root of the first term, end with the square root of the last term, the third term. Sounds familiar. this time, instead of both of them or one of them having addition and one having subtraction, they're both going to have the same operation going on in them. How are we going to decide that? We're going to look at the middle term. If the middle term is positive, both your binomial factors will have addition. And I think as you work these, you'll understand more why. If the middle term is negative, or in other words, it has a subtraction going on in front of it, then both factors will have subtraction. So remember, when we have a perfect square trinomial, it's a binomial times itself. So they both got to have the same sign going on in them. So first thing we're going to look for this time is, first of all, do we have addition going on here? Because you know what, if we don't have a positive last term, it's already down the drain. We can't call it a perfect square trinomial. Well, this one does have its addition at the end, a positive 1. So now we're going to check, is this a perfect square? Is this a perfect square? So we're going to write it and see if we can take the square root of 9x squared. Square root of 9 is 3. Square root of x squared is x. Can we take the square root of 1? Yep. 1 times 1 is 1. Middle term. We still have that to deal with. We have this plus 6x. That has a standard to meet also. Remember, it has to be 2 times the square root of the first term times the square root of the last term. When you multiply that out, we get 6x. It has to match that middle term. And it does. So good news, we can write the factor name because this is a perfect square trinomial. Both factors will start with the square root of the first term. Both factors will end with the square root of the last term. Because our middle term is positive, both factors will have addition in them. Shortcut way that we might see this written in an answer bank, a binomial times itself can be written this one could be written 3x plus 1 to the second power. Okay, one more. We got another trinomial here. We're going to check to see if we think it's a perfect square trinomial. First check, is the last term positive? Plus 9, it passes that test. Next test, are the first and the last terms perfect squares? So is 36x squared a perfect square? 36 is a perfect square. X squared is a perfect square. So sure enough, we can take the square root of it. It is 6x. 9 is a perfect square. Its square root is 3. Now it just has to meet the standard of the middle term. Our middle term is a negative 36x. Double the first square root times the second square root. I'm going to do 2 times 3, which is 6. 6 times 6 is 36. I do get a 36, and that's an x. But, whoopsie. But, we need a negative 36. So remember back here when we're taking the square root of 9, we can also have a negative 3 as a square root. So we're going to make it negative here so that we end up with our negative 36. We don't have to worry about making it negative here, though. Perfect square trinomial we just determined. Both of them will start with 6x. Both of them will end with 3. This time our middle term is negative. Subtraction in both. How would we possibly see this in an answer bank? You might write it in the shortcut method of 6x minus 3 to the second power squared times itself. Okay, so that's what we are doing in our homework today. In your homework today, it states that there are 4 that are no's or nots, because the question they ask you is this a difference of 2 squares? Or maybe they might ask, is this a perfect square trinomial? If so, factor it. So in other words, if you can say yes, do what we've just been doing. If you have to say not or no, then they say you have to explain it. So let's just do a number 2 actually in the homework. If you want to pause this just long enough to get your homework started. It's like this, x squared minus 4x minus 4. So there's 13 problems altogether to do. 4 of them are no's, nots, whatever you want to say, not factorable. This is a trinomial. So we are going to look for, is the last term positive? That subtraction sign in front of that 4 makes that last term negative. So we're going to say this is not a perfect square trinomial. But we don't get to stop there. We have to explain why. The last term is negative. It's supposed to be positive. It didn't pass that test. The last term needed to be positive. It is negative. There's our explanation. So we've just used up one of the no's, one of the nots. So there's 3 to go. Can't come up with any more than that. Otherwise that means the rest of them should be either a perfect square trinomial or the difference of 2 squares, one of our special products, and it can be factored. Okay, have at it. Good luck.